Alright, so in this video what we're going to talk about is an SQO, which basically is a sequencer. So what we're going to do is first we're going to throw our processor in run mode. Now there's no programming done whatsoever. There's no tags built, there's nothing. So you're going to see this from scratch. I'm not going to make it a real long video, but I am going to make it a video where you understand. So you want to come over here to sequencer. We're going to do sequencer just output. And this way you can kind of understand a little bit. I'm going to change the view just a little bit to kind of get maybe where you can see it just a tad bit more. Okay, so first and foremost, we have the array, we have a mask, and we have a destination, and we have a control. Control is just going to be your basically your SQO name. So we're going to call this, we'll just call this sequencer output. So we'll just call that sequencer output for the control. No big deal. Real simple, right? For the array, you want to know how many states you want to be in. Okay, so we're going to use this as an example of a state machine. So we're just going to say state array, and similar to what I've done before in previous things like state machines and stuff like that. We're going to give it a dimension though. We're going to say no more than 10 states. And then we're going to come over here. Now you can't just leave that tag like that. What you need to do is drag it down, and then you want to pick your very first state, right? So in this focus, we want to use the drop down, and I'm not sure why. Let's see. We'll use the drop down right here. I'll try to drag this down. I just changed my monitor, that's probably what it is. Anyway, this 4K is supposed to be better, but it's not. Anyway, so we're going to drag this down, try to get a little bit better. It's viewpoint. Okay, so there we go. We want to start at 0. Okay, so the mask, we're going to just basically say this is going to be the state mask, and we're going to keep that as a dent. It's going to be a single dent, no longer, no more than that, right? The output, basically, you'll have your output of whatever you're going to use in that statement. In this case, we'll have an output. We'll call this state, or we'll call that current state. And we can make that, but we're just going to make this a regular dent. We can make it a dimension, but we're just going to make it a regular state right here. So we're still, if you look at finalizing this right now, you're still going to have a problem. We need to put a length in there, and our length is going to be, let's just say 9. Okay, so then now we got rid of our problem, because our problem was we didn't have a length in here, and we still need to worry about our mask. So we're going to get a monitor. And if you don't know anything about a mask, this is basically what you, like if you wanted to mask something out, you wanted to ignore something. In the 31 states, or 32 states I should say, in the dent, which we're only using 10, but in the 32, we're not going to mask anything. So basically we're going to allow everything through, which is a -1. And at that point, you'll see 1s going through 0 through 31, which is 32 bits. So if you ever wanted to know how a mask works, and you've seen me use that before in the past, it's just that simple. So we can actually finalize this. We need to put some information in our sequencer, but first we're going to go put like some timers and stuff in here, so we can get by. And I'll just show you this actually working first, and then we'll go ahead and put like some logic behind it and see, how it transitions. But I want you to see, exactly how this does transition. It's really a simple process. It's not complex like everybody makes it. It can be a little complex if it depends on who makes it, but again, like any logic that's written, I mean, it's basically all up on it's all on the programmer, to be frankly honest with you. So anyway, so right here we're going to call this timer Call this timer 1. And then we'll go ahead and create that. And then this will be timer 2. And we're going to have to make that tag because we didn't make it. So we're going to have to create timer 2. And then we're just going to drag timer 2 up here. And that's going to be the done bit. So if it's done, we want to stop timer 1. And if timer 1 is done, we want to allow timer 2. And then we're going to give this like 1 second. Just to be just so you can see the states changing. So this will keep it really simple. And then, so for that matter, we got a free running timer. I'll show you that. As 1 second goes by, you can see that it does work. Let's do 2 seconds. It's a little quick. So let's do 2 seconds. And then we'll come over here, 2 seconds. So that's a total right there. Right, you can see that the timer on bit right here. So we're going to throw that timer in right here. Now we haven't added any kind of controls in our states yet or anything like that. But I want to show you realistically, like just simulating one. So you get the understanding of how a sequencer works, how the output sequencer works. So it's literally going through 1, 2, 3, 4, like position, like it's pointing to the array right now. So if I come up here and I go to the array, and in array 0, right, I say 0, but I say, okay, it's going to be 1 and 1, 2 and 2, and actually this is going to be 2, this will be 3, this would be 4, this would be 5, this would be 6, this would be 7, 8, and 9. Okay, so we have 0 through 9, which is 10. Okay, so for that matter, we're going to see now in current state. I want you to look at this. I want you to come down here, and we're going to add a rung, and we're going to say this is just going to be a move so you can see it. Now, granted, I'm going to put an NOP behind this, so don't fret. It won't work at all. It's just going to be a visual. So I'm going to basically AFI it in front of it, and then I'm going to NOP it in the back, which is a no operation. And that is, if you've never seen me use a no operation before, it's basically not going to operate. So I'm basically going to treat this as a move right here. So the current state right here, you can kind of see that. And you just see it cycling through right now, right? So you see it cycling through, and let's pull this back up where it goes. Pull this back up where it goes. All right, so you see, and let's see if we can't add a little bit more visual to that. So I'm going to bump that up just a little bit so you can see now where we're pointing to the array. Now I can change that array and use binary coded decimal. Okay, so just to show you the clarity behind this, if I wanted to, you go 2, you go 1, 2, 4, 8, then we'll go 16, 32, 64, 128, and then 256. So now if you come over here, you're going to see a completely different outcome. So you see we're indirectly, well, not indirectly, in this atmosphere we're actually pointing where every time this indexes, it's going to point to that section of that array. Right now we're in position 9, it's going to point to that bit. Now we can easily use that bit for whatever we want to, and just say, for instance, like whatever, like the current state. We can say current state, come down here and have a equal to, come down here and have an equal to right here. and then have the current state, and just say, for instance, the current state equals to, in this case, we'll just say equals to 8. And once it's equal to 8, let's just say we want to cut a valve on. We'll change that to OTE. And let's just say we want to cut a valve on or something like that. We'll just say valve 01 control. And that's just that simple, right? So now when it comes to that state, we're going to actually control that. Now we can control that just binary coded decimal like we're doing right now, or we can just use the bit. Okay, so there's two different ways to do that. There's two different ways to go about it. You can actually make this really complex, where you have multiple things, like you're using outputs and you're actually controlling multiple outputs at one time. But you see, it's as simple as what I'm doing. I'm saying if it's equal to 8, cut the valve on. If and generally speaking, you would say if the valve is on and the indicator switch is on, then transition to the next state. In this case, I'm just simulating the process. So what I was talking about earlier, let's just sample that again and go right up to here. And then what we'll do is I'll go up to current state. Okay. So in this atmosphere, what we're going to do is we go up and look at their array, and in state 8, right, we're using bit 3. Okay, so we can say bit 3 in current state. Okay, so in current state, we can come over here and say, well, we want to use bit 3. So in the equivalent to what we're doing, we could say and bit 3. So, and this is just, again, binary coded decimal, just to show you how that works. This is currently in 4. You can see when it goes to 8, that does cut on. So no longer do I need this, right? No longer do I need this, because I'm controlling it through the bit level of the actual output of the current state. So current state 3, right here, you can see right here, cut on valve 1. It's really a simple process. What I wanted to do is make sure, because like an output, or the sequencer output, can be really complex for most people to describe it, but I'm showing you the base foundation first, and so that you understand the mechanism behind what's driving what. Okay, so again, you're masking it right here, and again, if you don't want to mask it, you still have to put a mask. If you don't want to mask it, just put a -1. That gives all the bits in that 32-bit character. Then it will pass everything through. However many arrays you want, you can have as many as you want to. I chose to have 10, and then you just make sure your length is going to be coinciding with your array length. And then the output, the control right here is just naming the SQO instruction. The destination is going to be the current state. So literally we could say, like valve 1, 2, 3, 4. If we realistically wanted valve 1 to cut on in a different state, let's look at that real quick. If we wanted valve 1 to cut on in state 1, that's literally going to be right here is 0. So if we want to come over here and say valve 1, only cut valve 1 on state 0, then that's actually going to be state 1. And then we can say right here, down here, we can add that again and copy this and literally just change this to a 1, and we'll say valve 1 is going to get cut on here, and then we'll say valve 2 is going to get cut on here, or we've already cut on valve 1, and we say valve 2, right? So we can say valve, or actually let's just say pump 1 run command. Okay, so this will start making a little bit more sense to you, right? So if we're literally saying, okay, well, we want to cut on valve 1, and what we can do is we can say valve 1 is on right now, and then in this, and currently we're in state, we're in the next state. This is state 3. State 1 is on. What we need to do is come over here, look at current state up here. We need to look at why is that still on, because in state 1 we're using 0. Oh, because that's I used the wrong thing. So keep in mind, you make sure you, and this is how things can get a little skewed, if you would. So again, I used the actual array, and instead I wanted to use the control. Just like right here, I want to use the control. Okay, so change that to 1 and 1. So I want you to see that work before we go any further. So when it goes to, literally when this position goes to 1, the valve will cut on, and then when it goes to 2, the pump will cut on. So 1, valve cut on. State 2, the pump cut on. Now we can verify that the valve did cut on and not transition again. When it comes down to it, we can not transition. We can literally say if in state whatever, like say for instance, if this is on, we can say right here, come over here, put this in here, and put that in here, and literally say, okay, well, we want to make sure the valve got cut on. Okay, so we want to make sure the valve got cut on before we transition, and then we'll copy this, paste in here, and then I'll put a little AFI in here right now. I'll put a little AFI in there right now just to kind of show how that would work. And then we'll come over here and throw this in here and say, okay, well, for instance, if valve, we're verifying the valve 1 cut on. If in the next state the pump cut on, then we want to continue. Okay, so we just come over here and we can start driving the whole mechanism just like this if we want to. It doesn't have to be really complex. It can be very simple. So I don't like right now we're currently in position 5. It's not going to transition anymore because we're not actually actuating anything. So I'm literally going to start at 0, and then I'm going to go to 1. Okay, so 1 in a state of 1, or the output of 1, the destination. Let's see, it's not on, it's not enabled. So we want to actually we want to change the way we're doing this a little bit, because let's see right here, currently put in here, and let's make this transition. So let's keep that in there, and what we'll do for the sake of argument is come over here and say if valve 1 is open, then block it. And oh, by the way, if right here, if that's on, then block it as well. So what I did was I stopped the whole mechanism from working. So what we're doing right now is we're allowing it to cycle through. So I just wanted to show you can control this based upon, like for instance, right now it's going to continue to flow through because we haven't put any more controls in here. But in this case, when it goes to the outputs or the number 1 state, and then it's going to cut that valve on, then it will transition. So it will block it up here, and you'll see this cut on and this cut on. So right there, you'll see that transitioned, the valve cut on, okay, then the pump cut on, and it's not, and as soon as that transition, now it's going to continue on. So hopefully that adds some clarity to the way that whole mechanism worked with a sequencer output. instruction because it's not really that complicated. It's kind of like an FAL instruction, but again, when it comes down to it, you can use sequencers, you can use basically FAL instructions, you can use multiple, like just different, like state, like a finite state machines, if you would. I prefer a finite state machine because it's more direct. In something like this, you can put in a lot of controls and keep building on it and building on it and building on it, and then continue the process. But in the sake of argument, this has already been a 20-minute video, and I want to keep things simple. I want to keep things short, but in the same focus, if you're trying to learn how an SQO works, this video did accomplish that. And this video did add that clarity to it because, again, when it comes down to it, it's just as simple as what I just showed you. So hopefully you learned a lot from that video. We'll see you guys on the next one.